place value board. This is DIY as well. I just printed this. You can add more in my place value board. I just have ones, tens, hundreds, and thousands. All right. And I have this space for solving the math problem. You can add more. You can also print something that has a decimal frame. So if you look, it's like a 10 frame, just like what I drew a while ago. There are 10 squares. So I also have bingo chips. Okay, I used white to represent 1 unit. I used yellow to represent the tens unit, blue to represent the hundreds, and red to represent the thousands. So how do we use this place value board? So for example, I have, let me just look here. Oh, okay, hold on. For example, I have 545 plus 187. Okay. How do we use the place value board to add these two numbers? So again, this is easy for some students. If you know the process or the procedure, like mechanically, yes, it's very easy. It's so easy to solve this. But our goal is to help students make sense of what they're doing. So we are showing concrete objects. So first, we represent 545. So I have 1, 2, 3, 4, and 5. And then 40. So I have 10, 20, 30, 40. And then I have 500s. So this 1, 2, 3, 4, 5. So 545, right? There you go. Now we need to add 187. So let's begin with the ones digit. Let's add 5 and 7. So I already have 5 ones. I need 7 more. So 1, 2, 3, 4, 5, 6, 7. There, I added 7. But as you can see, okay, I don't have enough space. Okay, I don't have enough space here to fit these other 2 ones. Therefore, I need to regroup. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5 plus 7 is 12. Can I put 12 here in the ones place? No, we can't do that because we can only put 0 to 9 digits there, right? And I have 2 digits, 12, 1 and 2 has 2 digits, 12 has 2 digits, and we can't do that. Therefore, we need to regroup. So I will remove this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will regroup this 10 once and replace it with a 10 chip because that has a value of 10. I can switch and exchange it with the 1 chip that has 10. Okay, so this can be removed and I can just replace it with 10. Okay, and I can move this up. All right, therefore, if I do that, okay, the 10 ones that was here, it now went to the next place value. So we regroup it and we have 110 here. All right, and what is left in the ones place is 2. That's why you carry over. It's a concept of carrying over. So we have 4 plus 1. We have 5 tenths plus 8. So we will get 8. 1, 2, 3, 4, 5, 6, 7, 8. As you can see, again, it's not enough. We don't have enough space. Therefore, we need to regroup. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 tenths. That's 130. Can I put that there? No. Okay, we just need 0 to 9 digits. Therefore, we need to regroup. So we put this on the next base value. So 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that has a value of 100. Therefore, I can switch or exchange that with a 100 chip. There's your 100 chip. So this 100, I can replace it with 1 chip, which has a value of 100. Now there's space for this 3 tenths. All right. So I'm looking for the digit to write on the tenths place. And as you can see, how many tenths do I have here? I have 1, 2, 3. I have 3 tenths. Okay, and the other tenths went on or are moved or are grouped to the next place value, which is here. So I have 100 there. All right, so I have 1, 2, 3, 4, 500s plus 100 there, plus another 100 over there. Okay, now I have 700. 1, 2, 3, 4, 5, 6, 700. So therefore, the final answer will be 732. Okay, so this will show them the concept of regrouping. Okay, why are you carrying over? Okay, because why are you carrying over? Because if you look at the place value, okay, it doesn't make sense if you put 130 in the tens place. How do you do that? Okay, there's so many digits there. Okay, so there. So we can use that for addition. Another example, we can use it as well for subtraction. So for example, I have 765 minus 392. All right. So first, let's represent 765. 1, 2, 3, 4, 5, 6. I have 7 already. 700. And then 60. So 10. Subitizing, that's 6. All right. And then 5. You know what 5 looks like. This is actually another way to help your students subitize because it looks like a 10 frame and they can right away see if they have put the right amount of chips. Okay, so I have 765 here. Now I will subtract 392. So let's begin with the ones digit. I will take away 2 from this 5. So remove this 2. So how many are left? I have 3. Next, I will take away 9 from 6. Oh, how will we do that? I have 6 on the tens. I will take away 9. Do I have enough? No. So the children will see that you don't have enough. Therefore, you need help. Okay, you need to regroup. You need to borrow from the hundreds. Therefore, I will get, can I borrow 10 tenths from the 100? So I will get this 100 and trade it. Trade it with how many tenths are there in 100? There are 10. Okay, so let me get that first. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so I have 100. Okay, I can switch this, exchange it, okay, with 10 tenths. All right, so I'm gonna remove the 100 chip and switch it with this. And since they are all in tenths or in 10 chips, I can put it here in this area, the tenths area. Now, if you look, I don't have enough space because I have lots of tens there. So just put it there at the bottom. Now I have lots of 10, 20, 30, 40, 50, 60, 70, 80, 90, 20. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50, 60, 160, where I have 16 tens. So a while ago, there were 700s here. I took away 100 and replace it with the tens. So now I just have 6 here. All right. And then I regroup it and put the hundreds or the 10 tens here in the tens value. So, and then we counted, I had 160, or that means I had 16 tens. Again, we are in the tens place. So I had 16 tens. Now I have enough to remove 9 tens. So I will remove 9 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so how many are left? So as you can see, 7 tens are left. This is the tens place. I will write 7 tens, 10, 20, 30, 40, 50, 60, 70, 7 tens. And then we can move on to the next place value. So we have 6 here remaining, and we will take away 3. Let's take away 3 hundreds. 1, 200, 300. Okay, so how many are left? You have 3. Therefore, the final answer is 373. Okay, so here it will help the children make sense of how the borrowing works. Okay, so especially when you have, for example, 1009 and you have 00 here. Okay, sometimes the children get confused with that. Okay, so this concept will help them think about that. Let's have that as an example. One more. Okay, let's have, for example, 1008 minus, let's say, 350 here. Okay. Okay, for example, that one. Let's try that. Okay, so let's show 1008 first. So I have 1000 and 8. 1, 2, 3, 4, 5, 6, 7, 8. There, 1008. Now I will remove 350. Okay, so how will I do that? I will begin here. So 8 minus 0. I will not remove anything from the ones. So I will not remove anything from this frame. I will move on to the next. On the tens, I will remove 5 tens from 1008. So this is 1008. I will remove 5 tens. There's nothing in the tens. So how will I remove 5? Okay, what will we do? We will regroup. We will get from the hundreds, but there's nothing in the hundreds as well. So what are we gonna do? Then let's borrow from the thousands. All right, so this is your thousands. We will trade it. How many hundreds are there in thousands? There are 10 hundreds, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Okay, so this is 1000. So instead of having this, I will trade it to 10 100s. All right, so I'll remove this one. Now I have 1000 here. Okay, now I still can't remove 5 from the tens because there's nothing here. So I will regroup again. I will get, I need tens here. So I will get 100 and trade it with 10 tens because 100 is 10 tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so that's 100, 110, the 100, 10 tens, which is 100. So I can remove this because I have the 100 there already. Now, can I remove 5? Yes. Now, we forgot to take note. Every time you regroup, always take note of it here in this word problem. So a while ago, there was 1,000 here. We took it away and switched it with hundreds. So we had 10 hundreds here, right? But then we still have nothing to get for the tens or from the tens. So we took 100. Okay, from 10 hundreds, 10 of the hundreds, we took 1, so it becomes 9. All right, and then now I have 10 tenths. Now, can I remove 5? Yes. So 1, 2, 3, 4, 5. So take away 5. How many are left? You will see there are 5. Okay, now I have here 9 hundredths left. 9 minus 3. So I will take away 3. 1, 2, 3. What's left? 6. Oh, sorry, I forgot to put 8 here. Okay, so 8 minus 0. You didn't remove anything, so that's still 8. So final answer will be 658. All right, so using the place value board is a perfect material for you to show borrowing, the concept of borrowing, especially when you have like zeros here on top, okay, so that they see the concept. All right,